Hi, today we are going to see about RAKE Receiver. Time diversity transmit repeatedly the information at different time spacings. Time spacing greater than coherence time, in which coherence time is the time over which a fading signal can be considered to have similar characteristics. So signal can be considered independent. The main disadvantage is the bandwidth efficiency significantly worsened. The signal is transmitted more than once. The RAKE receiver, powerful form of time diversity available in spectrum systems, is CDMA. The signal is only transmitted once. Propagation delay in the MRC provide multiple copies of transmitted signal delayed in time. Time diversity repeatedly transmits information at the time spacing that exceeds the coherence time of the channel. Multiple repetitions of the signal will be received with independent fading conditions, thereby providing diversity. Our modern implementation of time diversity involves the use of RAKE receiver for spectrum CDMA. The RAKE receiver attempts to collect the time-shifted versions of the original signal by providing a separate correlation receiver for each of the multipath signals. Each correlation receiver may be adjusted in time delay so that a microprocessor controller can cause different correlation receivers to search in different time windows for significant multipath. The range of time delays that a particular correlator can search is called a search window. If time delay between multiple signals greater than shift period of spreading sequence leads to multipath signals can be considered uncorrelated. In a basic system, these delayed signals only appear as noise since they are delayed by more than a chip duration and ignored. Multiplying by the chip code results in noise because of the time shift. But this can also be used to our advantage by shifting the chip sequence to the receiver that delayed signal separately from the transmitter. Activity. In RAKE receiver, m branches or fingers is equal to hash of correlation receivers. It separately detects the m strongest signal, then weighted some computed from m branches. A RAKE receiver is a radio receiver designed to counter the effects of multipath fading. It does this by using several sub-receivers called fingers. The RAKE receiver was patented in the US in 1956 by Price and Green. Each correlator detects a time-shifted version of the original transmission, and each finger correlates to a portion of the signal which is delayed by at least one chip in time from the other fingers. This will result in higher SNR in multipath environment. Multipath component appears like uncorrelated noise at a CDMA receiver, and equalization is not required. The output of each correlator are weighted to provide a better estimate of the transmitted signal than is provided by a single component. The weighting coefficients are based on the output power or the SNR from each correlator output. If the power or SNR is small out of a particular correlator, it will be assigned a small weighting factor or vice versa. In outdoor environments, the RAKE receiver delays between multipath components is usually large. The low autocorrelation properties of a CDMA spreading sequence can assure that multipath components will appear nearly uncorrelated with each other. In indoor environments, the RAKE receiver in IS-95 CDMA has been found to perform poorly since the multipath delay spreads in indoor channels are much smaller than an IS-95 chip duration. In such cases, a RAKE will not work since multipath is unresolvable. Relay flight fading typically occurs within a single chip period. This figure shows the bit error rate of the RAKE receiver. Assessment questions. Thank you.